Hello, we are Group 106. Our device is the Angler, a novel 810 nanometer LED transcranial photobiomodulation head cap device. We're joined today with Caroline Carter, Sal Miller, Claire Sissons, and our mentor, Dr. Honey Liu. There currently is no high-powered LED devices used for transcranial photobiomodulation, also known as TPBM, on the market. TPBM has known to treat a variety of mental illnesses, traumatic brain injury, and improve cognitive function by quantifying CCO, which is cytochrome C oxidase, total hemodynamic blood oxygenation, also known as HBT. These are our two values will be used later. Our high-powered LEDs are not commonly used for TPBM due to its low power density and overheating, causing discomfort for the subject. Our device needed to be under $800, lightweight, have a working cooling system, and produce these quantifiable changes in vivo.
Features of our final design include vents on the sides for airflow, foam feet for comfort, a rim along the top that the fan fits into, a hole in the bottom that the LED goes through, and then the box is printed out of NinjaFlex polyurethane filament, which is flexible to protect the circuitry inside. We only utilized one 10-watt high-powered LED to achieve our optimal power density of 135 milliwatts per centimeter squared with a heatsink attached. We went through many box iterations to reach this final design. In designing our circuit, we initially tested it on a breadboard before soldering it to a PCB board. We soldered it in parallel to decrease overheating chances, and we included a switch for easy operation. We created a separate box printed in ABS plastic to hold the wiring and our PCB. There's 3 holes in it, one for the wire, the switch, and then the out wires. There's a lid on top to protect the circuitry. Components of our design included an adjustable DC power supply to maintain the optimal power parameters, and then a head cap, which the LED box attaches to via Velcro for maximum targetability.
So this is an overview of how our system works. We start with the adjustable power supply, which sends signals to our circuit box, and which turns on the light and the fan in our Angler device. This is all of our components together, and it's connected by the little white wires in the back. So these were our optical power density tests done at 0.93 amps and 1 amp. At 0.93 amps of our design, our LED gave 119 milliwatts of power, and at 1 amp of our design, at 5 volts, it gave out 136 milliwatts of power. We wanted it to be around 135 milliwatts, so this means our design's functions were successful. This graph of results show the temperature of our LED on the back on the metal under different conditions over time. So the first one on top, this little one right here, is just the LED by itself. The second one was the LED plus its heatsink, thermal tape to the back, and this last one was the LED, the heatsink, and the fan all together. This shows that we do have a working cooling system.
Here are our results. For the concentration of HBT, the total hemoglobin, a pre versus post over time. The blue values indicate the pre, the red indicates the post values. As you can see, we have a peak concentration of HBT at approximately 1.2, and we have a constant linear trend showing that there is a statistical difference between pre and post stimulation. The concentration of our metabolic quantity, CCO, of pre versus post over time of 8 minutes. Again, the colors represent pre and post. T-tests proved to have significant differences between both quantities. In conclusion, our device has met the proper parameters that has been found by measuring the power at different amperages and maintaining optical density. Heat tests prove that both the fan and heat sink are needed to keep the LED within 90 degrees Fahrenheit and room temperature. Our head cap was voted comfortable and secure by our population size. BB-Near's testing was able to prove quantifiable changes in hemodynamic and metabolic data. In conclusion, our device is able to produce quantifiable changes and has met all parameters needed, and thus is a novel TPBM device.